So hello. So today the problem of the day of the lead code is product of the last k numbers. Okay. So we are going to solve it and see what is the best approach to solve this. Okay. So what the question is saying basically it's simply straightforward that we have to this basically question is a design problem. Okay. We have to design a class of two functions, that is add function and get product function. Okay, so the class name would be so the initialize, so the constructor name is the product of numbers. Okay, that will be initialize the object with an empty string. Okay, so what we have to do is that we have to implement this product of numbers class. Okay, so we have given an string. Okay, uh, and the add function will add the numbers in it. Okay, and we have to calculate the product. Okay, from the last of k, like if there are 5 numbers, then we have, and the number given, the basically we have to calculate till 2. Well, if we have given get product 2, then simply we have to calculate the last 2 digit product of last 2 digit number. Okay, so this is the question. Okay, we have to form a basically class. Okay, where we have given two functions, that is add and get product. Okay, get product is like product of the last k numbers that we have to calculate from that string. Okay, so this is whole question. Okay, so how will we implement it? Okay, so the brute force could be like if we see brute force, what will the brute force? Simple, the brute force will be like if we calculate like if we traverse through array and then simply calculate the product of the last k digit number. Okay, it will be so difficult because the k value is so higher and the num value is k is so much higher. Okay, the 10 to the power 4, basically 4 into 2. So for this the basically it will be so difficult and the time complexity will be so high. Okay, so the it will simply be maybe given runtime error. Okay, we can't use, so interviewer will not be happy with this. Okay, so we will use a optimal approach. Okay, for this to create this class. Okay, main here thing is basically get product, that we have to calculate the product of the last k number. Okay, so we will not use brute force. Okay, we will use, here I have written that we will use a prefix sum approach. Okay, so first I will tell you what is prefix sum. Okay, prefix sum is like a that we have to calculate, like we have given an array, we have to calculate the sum of a sub array. Okay, we will simply, what we will do is brute force will be like we will iterate through and we will simply add them. Okay, and we will get the answer. So to minimize this approach, okay, minimize the time complexity, instead of recalculating the sum, okay, again and again recalculating the sub array sum, we will simply, what we'll do is we will use prefix sum. What we'll do is we will pre-compute the sum once and use it later. Okay, we will calculate every, just like I will explain with example. Okay, let's say we have an array. Okay, 25183. Okay, so the prefix sum array will store the sum of elements from the beginning up to that index. What is saying that if index is 0, then simply array of I is 2. So the first index is 2. So then prefix sum will also be 2. And the second index is 1 and then number is there 5. Okay. So simply what we'll do is we will add 2 plus 5 equals to 7. Okay. And then for second we will add previous to next. Okay, like previous was 7, then we will add next element, that is 1, simply 7 plus 8, and this whole approach we will add all this, and our answer or prefix array would be like this, prefix 2 7 8 69. So every index the prefix sum array is this. Okay, so why are we using prefix sum? Okay, so let me explain. Okay, if we want the sum of array of any sub array, like in this array we have let's assume that we have to calculate the sum of like this, one index, okay, 1 to third index, okay, 1 to third index, 0 1 2 3, okay, last, or we can say last, 1 to last index. Okay, so how will we do it? Like if we use simple sum, then it will be simply like so large, okay, and time complexity so higher. Then if then we will use prefix sum. Okay, so how we'll do it? Sum of L to R, like if we see that L is the position, initial position to last position, it is prefix R in prefix sum from the R index minus prefix L minus R. Okay, this would be R. Okay, so example, like find the sum of element from index 1 to 3, that I have taken the example, array 1 to array 3. So what will the normal sum will be? 5 plus 1 plus 8 equals to 14. Simply this will be the normal sum. And if we use prefix sum, then simply prefix 3. What was the third index? It was simply 16. Okay, 16 minus prefix of 0, because we have to array 1. Array 1, basically 1 is like this. Okay, so it will be like prefix 0, what is 2. Okay, because we have to include these 3, so we will simply minus with this first element. Simply 16 minus 2 will be 14. Okay, so you got the approach. What is this? So this is basically faster. Okay, the time complexity is simply building prefix sum arrays big O of n. We will traverse through arrays, so it will take big O of n, and querying, like adding or simply getting the value, getting the product is big O of 1. Simply we will minus and use it. Simply it is useful when we need to calculate sub-array sum. Okay, sub-array sum are basically so easy to calculate with prefix sum. Okay, so basically you got this approach of prefix sum. Similarly, we will use prefix product in this question. Okay, so what is prefix product? Same as prefix sum, just we will use multiply sign instead of plus sign. Okay, so the approach will be like, we will initialize it with prefix product array, in which we will just store the every prefix product till that index. Okay, and when we encounter 0, okay, so the main question is here, when we encounter the 0, because if we multiply it with 0, whole array will become 0, so we have to return it 0. Okay, so in this we will, what we will do is, we will initialize again with product array as 1. Okay, and size will become 0. So first we will initialize it with, okay, when we initialize the prefix product array, we will use as a first index as 1, because if we multiply it with 1, the product will not be changed. Okay, we will not use 0. So if we encounter 0, then we'll simply initialize again with product arrow, no matter how the array has become, how the big the array has become or the size has increased, we will simply again initialize it with 0 and the product array as 1. Okay, all elements will be gone and the element will be simply remain as 1. Okay, so this is the formula how we are going to calculate the last product of k element, basically last product of last k element. Okay, so I'm gonna use the example here. Okay, so this is basically the first example that is given on the LeetCode. Okay, so here's the first, it will initialize product of numbers, that is the basically constructor that simply initialize the prefix product array with value 1 and the size will be 0, this. Okay, then simply the functions will start. First we have to add what? 3. Okay, simply it will 3 into 1, the previous element is 1 now, then simply it will give 3 into 1 3. We can also use size. Okay, size will be 1. Okay, size plus we will use. Okay, size will be now 1 for first iteration and for first function. Okay, then simply we have written that add 0. Then the main thing comes here. We will simply initialize again with product prefix array 1 and the size will become again 0. Okay, and then again we have to add 2, then simply we will add 2 and the size will become 1. Okay, simply size will become 1, and then we have to simply calculate the prefix product. Like if we give 5, then simply 2 into 5 is 10, and the size will become 2. Okay, and then simply for 4, it will simply multiply in 10, then it will simply give 40, and the size will become 3. Okay, so these are the sizes it will become, and then the get product started. Okay, so the get product is first, that is 2. 2 means that we have to give last product of last two elements, that is 4 5 is 20, so the answer should be 20. So what will that, the formula is return basically prefix product k, that is okay, k, what is the k, is the last product of last k elements. Okay, what will the last product of k element, that is prefix product size, the size till the this function. Okay, okay, the size is 3, so simply we will use here the prefix of third index. Okay, third index is here, so it will give 40, and the 3 minus 2, that is the 2 k, basically k is 2, the 3 minus 2 1, simply what it will give is, that will simply 40. Okay, 40 divided by 2, so because at the 1 was element prefix sum was 2. Okay, then we have to then we have given third, so the last 3 4 5 is 20, 22 is 40, we have to return 40. Simply the prefix product prefix is size is 3. Okay, and it will simply give 3 minus 3 0, so 40 upon is 1. Okay, because at the 0 index it is 1. Okay, simply it will give 40. Now you should thinking that it is 0, and then why we are giving that, we have to calculate till here, not till here. Okay, okay, last 3, these are the last 3 elements. Okay, so 0 is not included. Okay, so then next, for next iteration we have to calculate 4, so these 4. Okay, so the now answer will be 0 because the it has 0. So if we see that, if now what will happen, prefix size is 3 and the k is 4, and so if we write here, then it will simply 3 minus 4, that will simply is out of bound. Now the condition comes, if this happens, what happens, that if k is greater than size, we will simply return 0. Okay, you got the thing, we will simply return 0 if the k becomes greater than size anytime. Okay, for next then iteration, it will it has given that add, we have to add 8 in this. Okay, we will simply add here 8. Okay, the iteration would be that 8 4s are 32, so the total would be 320. Okay, and the size will become 4. Okay, simply, and then for next we have to get product of last two elements. So simple, we will just, I'm gonna copy paste, and here the answer would be, the last two elements are, what are the last two elements, this 8 and 4, it was a 32, so the answer should be 32. So the uh, now size is 4. Okay, and the answer should be 4 minus k. Okay, the k is 2, so 4 minus 2 is 2, so prefix at number 4, the is 320, so it will be 320, and the here basically 4 minus 2, 4 minus 2 is size number 2, so here is 10, simply we will write 10, and the answer would be 32. Okay, so you got the thing, this is the basically the approach of prefix product that we will use in our code. Okay, so this is the basically approach, and I will provide you the code, so and I will explain you also the code. Okay, so the code is here, so here's the code, that is product of the last k numbers. Okay, this is the code. We have first initialized the vector, that is product, that is basically prefix product vector. Okay, and we have initialized size with 0, and we have also initialized here also in constructor. Okay, that will simply give product and push back the 1 as the first value in the product array. Okay, and size will be 0. Okay, and first we have to add, the function is add, and add simply I have done is, if the number is equals to 0, then simply we have to reinitialize the product with 1 and the size will be 0. Okay, I have told you in the code approach. Okay, and if the number is not equal to 0, then simply we will push that with the multiplication of previous product. Okay, till that till previous size. Okay, and simply multiply it with the this number and we will increment the size also. Okay, and then in get product function, the k is given. The k is the basically last the numbers that we have to calculate, the last product of last k numbers. Okay, and if k is greater than size, simply I have told you at every time the k becomes greater than size, we have to return 0, and if not, then we have to simply return this product size divided by product size minus k. Okay, so it will simply give the product of the last k number. Okay, this is the code I will provide you in the GitHub, so please like and subscribe. Okay, so okay.